Back in business. Okay, so we're factoring trinomials. Remember that when last unit we talked about quadratic functions in standard form. F of x equals ax squared plus bx plus c. Well, we're just going to be looking at just that part of it, the trinomial part, right? That's a quadratic trinomial. Okay, tri means three. So it's a polynomial with three terms. It's got an x squared term, an x term, and a constant. This is different than the stuff we looked at yesterday, right? When we looked at the difference of squares term, that's a binomial, has two terms. So first we're going to look at the very simple case when a is equal to 1. If you're factoring quadratic trinomials where a is equal to 1, they are super easy. Could not be easier. So we know that they're always going to factor if they factor, and they won't always factor. But if they do, they're going to factor into a template like that, right? Doesn't that make sense? Because factoring is undistributing. Well, if I were to distribute here, when I distribute the x to the x, I'm going to get my 1x squared term, right? The question is just when we are factoring this trinomial, the only thing we need to determine is what are the magic numbers that go there and there? I mean, if they exist. So what would they have to do? What's our recipe for the magic numbers? They have to multiply to, no, 15. They have to multiply to the constant and add to 8. And why would that be? It's easy to remember because these numbers, when I'm distributing, when I distribute that last number to the last number, I'm going to end up with this magic number times that magic number is going to give me the term with no x's in it when I FOIL that out, right? That makes sense? Okay, so we'll play the sign game here. We know that the magic numbers have to multiply to 15 and add to 8. Start with the signs. If they're multiplying to a positive, what's that tell you about the signs? They're both the same, right? If they're multiplying to a positive and adding to a positive, then I know that the signs are both positive, right? Yeah. So I can put a plus sign and a plus sign, and then I just have to find them. What are the numbers? 5 and 3. There we go. And we're done, right? Okay. Give me 1 to 5. So you guys remember doing that? Probably did that 1,000 times over the last couple of years. Okay, so what about, let's try just maybe a couple more. How about this one? What would I need to do there? Greatest common factor. We always try that first. What's my GCF here? Good, we can undistribute a 2x, leaving us with what? X squared, okay, because I have 2x times what is 2x cubed? X squared. Minus 2x. Minus 15, okay? And so we've got our 2x, that's a factor, that one's out front. And now we have to determine, could we break this trinomial up into, could we break it up using magic numbers? Do they exist? They have to multiply to what, everybody? Negative 15 and add to negative 2. So if they multiply to a negative, what's that tell you? Opposite signs. If they multiply to a negative and add to a negative, which of the two is slightly bigger, the positive or the negative? The negative. I always like to put the biggest one first, like that. What are they? 5 and 3. Negative 5, positive 3. Okay, again, 1 to 5. No problems, right? I was going to have you guys do board work, but let's not even bother with this stuff. I don't think we even need to with the simple ones, right? You guys are so familiar with these. Just do this one. I tell you what, crank this out on your scratch paper and we'll go through it here real quick. Do that first one. Okay, so what are we getting? What are the magic numbers, Oscar? There we go. X plus 5, x minus 9. Good. Okay, how about here? I'll tell you what, let's do one more. I'm just going to make one up. Let's do this one. Let's see. X squared. What'd you get? What do you think? Doesn't factor. It's prime. Okay. Okay, so the answer is you just leave it like that. Okay, so what makes it prime is that there are no magic numbers. Yeah. Yeah. And that's kind of honestly, that's kind of a dumb concept in a way, because when we say things factor, at least in algebra 2, when we say things factor, what we really mean is they factor conveniently using integers, right? I mean, this may actually have solutions, and they just might be really inconvenient factors. But when we talk about factoring, when we say something's prime and we're referring to factoring trinomials, we just mean it doesn't factor conveniently. Now, what we're going to do later on then, we're going to end up with 4 techniques for solving quadratics, and the first of the techniques is solving by factoring. We just would move on. We wouldn't use that one. Okay. All right. So now we move on to the little more complicated ones. Now we're looking at cases where we have trinomials where a is not equal to 1. In this case, for example, a is equal to 6. Okay. Now we'd always try to undistribute something, and sometimes that solves the problem when a is not equal to 1. Sometimes we can undistribute a GCF and we end up with a trinomial where a is 1, and it's easy. This time, no such luck. So what do we do? Now there's 2 techniques for this. I'm going to show you guys the one that you already learned first. You learned slip and slide, right? Or do you call it bottoms up or slip and slide or something? Say it again. You should. If this, I hope I organized this thing right. So this would be, oh, okay, no, you really don't. Gosh, I thought I did put that in here. I don't think you do. Darn it. Somehow that didn't get in there. So put this on a separate piece of paper. How about? Yeah, you don't have this one in there. Tell you what I'll do. I will print out. Okay, remind me at the end. I'll print one of these out, and I'll just give it to you separately. That sheet. Okay. Yeah. For now, just kind of write these down, and just you're going to remember them anyway. Okay. So what do we do here? When a cannot be factored out by greatest common factor, what can you do to factor the trinomial? This is one little trick for doing it. I don't like this technique. I really don't. It works and it's a trick, but it's not algebraically rigorous to do it this way. I'm going to show you a way I think is much better for an honors class. I would much prefer you don't do it this way. I'm just going to show it to you once to remind you how it works, but it's really not a great way to do it, honestly. It's not. It's not a great way because the steps are not logically equivalent. It's kind of like, I'll show you how you would do this one. Well, you can, but you have to be careful how you show it, because like if you show the steps wrong, you might be setting things equal to each other that actually aren't equal to each other, and the algebra is incorrect. You'll see what I mean when we do an example. So what do you do here? If you're going to use slip and slide, you're always going to slip a to the end and multiply it by c. Okay. So step 1 is going to become, we're going to take this thing, we're going to multiply a times c. We're going to get 6 times negative 28. Okay. And that's going to give us a basic trinomial. Okay. So that's going to give us what? X squared plus 13x. What was that, Oscar? So minus 168. Okay. Now look at the advantage of this is then it gives you a basic trinomial where a is equal to 1, and we just find magic numbers the way we did in the last few examples. So what about these magic numbers now? We got to factor this new basic trinomial. So that's an x and that's an x. We have to see if magic numbers exist that multiply to negative 168 and add to 13. What does that tell us about the magic numbers if they multiply to a negative and add to a positive? One's positive and one's negative, and which one's bigger? The positive one. And how much bigger? 13. Yeah. So this is going to be a plus, and that's going to be a minus. And so one way, when you're trying to find like big magic numbers like this, there's a couple different approaches you could take. You could find factors of negative 168 and just see if you can find factors of negative 168 that add to 13. That's kind of hard to do though, right? Finding factors of negative 168, it's inconvenient, right? So I've got another way I would encourage you to do this one. When you're doing, and so I don't want to make this too much of an art form but this is good number sense stuff. When you're trying to find numbers that multiply to a negative and add to a positive or a negative, here's the approach you would take. Oh, what did I just do? There it is. There we go. Okay. I want this one. Okay, I'm going to use this table. If our magic numbers are m and n, m plus n has to equal what? What does m plus n have to equal? 13. So m plus n has to equals 13. So I'm just going to pick positive numbers and negative numbers that add to 13, and I'm going to calculate the sums and see if I get one that multiplies to negative 168. That's easier to do. Like, for example, what could I start with? If I pick m to be, like, let's just say 18, what would n have to be so the sum is 13? Negative 5, right? What's the sum of 18 times negative 5? No. Negative 90. There we go. Negative 90. Okay. Okay, so now we've got to get numbers. So what do I have to do? I need my product to be bigger than that. So what do I need to do? I need to make m bigger, don't I? Right? Need to make the numbers bigger. Let's skip down the list a little bit because we're not even close, right? So let's skip down. How about 20 times negative 7? Negative 140. Okay, I'm getting closer, right? So let's go 21 and negative 8. What's that give us? Ah, there we go. Okay, now what if we had jumped from negative 140 to like negative 170? What would that have told us? They don't exist, right? The magic numbers don't exist and we're done. It's prime. Okay, make sense? But we did find them. It's right there. Okay, so we factor the basic trinomial, which we did. And then step 3 is, what did we get? So we got our numbers were plus 21 and minus 8. Okay, step 3, we're going to divide both of our factors by the value we slipped over in step 1. So we mean the magic numbers. By the factors, we mean the magic numbers. So the next step then is going to look like this. X plus 21 divided by what? Yeah, by 6, right? Because that was our number that we slipped. That was A. So x plus 21 over 6 times x minus 8 over 6. Okay, last step. We're going to reduce the fractions, and then if they're still fractional, if I still have a denominator other than 1, I'm going to slide the denominator up in front of the x. Okay? So what does 21 over 6 reduce to? 7 over 2. Okay, so we have x plus 7 halves times x minus 8 over 6 reduces to 4 over 3. And then the last step is, if we end up with a denominator, we slide the denominator up in front of the x, and so our final answer looks like this whole thing is equal to, what does it equal? It equals 2x plus 7 times 3x minus 4. What's the disadvantage of this method? Well, all this stuff we did, I had to kind of do on the side because none of these steps up here are equal to what I started with, right? And usually in math, what do? We have an expression and we go down to the next line and we say it equals something, and then I do some algebra and it equals something else that's equivalent to that, and I just keep doing algebra steps until I make it look like what I want it to look like, right? In this case, I didn't do that. This was all just a bunch of weird side work that we did, and when I follow those steps, I find out what my original expression was equal to. Okay? Make sense? Okay, so let's practice that, and then I'll show you a better way. So what about this guy? We're going to follow those steps, right? We know the steps. Slip a to the end, factor the basic trinomial, divide all the magic numbers by a, reduce the fractions, and slide denominators forward, right? There's our steps. Okay. Can I undistribute anything? No, I'm stuck. Okay. So what does my basic trinomial become for step 1 here? Okay. So again, I've got to do something kind of inconvenient here. I've got to find numbers that multiply to negative 360 and add to 54. But again, because they're multiplying to a negative and my magic numbers have opposite signs, I can use this trick that I used before, right? Where instead of trying to start with factors of negative 360, I'm just going to choose numbers that add to 54 until I find some that multiply to negative 360. Okay, so there's our, so the sum this time equals 54. The positive number is bigger, so we'll make that m. And if we started off, let's just start off with something like, well, actually, this one's, can you see what it is? 60 and 6, isn't it? Right? 60 and negative 6 are going to add to 54 and multiply to negative 360. So those are pretty good numbers that time, right? What if we started at a place on the table when the product was too big? What would I have to do? Got to go back up and pick smaller numbers, right? Okay. So we got our numbers. X plus 60 times x minus 6. Okay. Let's combine some steps here. What would I do with my magic numbers? Divide by 8. Okay, so let's just do that. And now we'll reduce, right? Okay, so what does that reduce to? 15 halves and x minus 3 over 4. Okay, when I reduce, if I get an integer, then I don't have to slide anything up, right? There's no longer a denominator, and that factor would just be done. Okay. In this case, we do need to slide twice, though. And what do I get? 2x plus 15, 4x minus 3. So there's my answer. Okay? Give me 1 to 5. Is that all making sense? Okay, and I'll give you that handout. I bet you want to try one on the board? Okay, why don't you let's do, okay, just do example 1 real quick. So yeah, this time we want to find numbers that multiply. Okay. So this time it's a little bit different. When we have numbers that multiply to a positive, what we have 30. Now you have to just find factors of that number. We know that we want factors that multiply to 30 and add to negative 17. So they're both negative, right? And we would just pick values. Like if I pick something like, I want you to notice a trend here. If I pick negative 30 and negative 1, they add up to negative 31. They're supposed to add up to negative 17. That's too big, right? How do I get the numbers to add up to something smaller, the factors? Yeah, I got to make them closer together, don't I? Right? I've got to make the number smaller. So I could do something like negative 15 and negative 2 gets my negative 17. If I kept going and I did negative 10 and negative 3, I passed it by. Right now, the numbers got too small. The bigger, the wider apart the numbers are, the bigger the sum is going to be when I'm finding factors. So this was the winner. Okay. You guys see the point I'm making there? Okay, this is how you would have probably normally done it in years past when you're finding magic numbers. Make a factor tree or something. Want to find factors of a number and then just pick the ones that add up to the right amount. Okay? Okay, now moving on. I'm going to show you a better way of doing this. So I'm going to show you a technique called factoring by grouping. Factoring by grouping is a really solid factoring technique in algebra. We'll use it next unit when we're factoring trinomials or polynomials that are bigger than trinomials. Like if we're factoring polynomials with like 4 terms, for example, then we would just go right to this technique. So what do you do? Well, we always want to try to factor out a GCF. Can I do that? No. So we'll just check that step off. A is not equal to 1. Now we want to find magic numbers that multiply to A times C and add to B. So they're the same magic numbers that we were finding with slip and slide. What is AC equal to this time? 36. So we want numbers that multiply to 36 and add to negative 12. Okay, what would they be? Negative 6 and negative 6. Everybody agree? Okay. So our magic numbers then, M and N, are both negative 6. So we're going to split this middle term up then. Negative 12x, we're going to split it up into negative 6x plus negative 6x. Okay, we're going to split that using our magic numbers. So this becomes 9x squared minus 6x minus 6x plus 4. And then we're going to group this. We're going to split those 4 terms up down the middle. And we're gonna factor by grouping. So this first group, first 2 terms, we're going to factor out a GCF. What is that? 3x. So we can undistribute a 3x, which leaves us with what? 3x minus 2. Okay, now this is the cool thing about this. What's guaranteed to happen, if I can find magic numbers, which I did, this is guaranteed to work, absolutely guaranteed to work. So then we're going to put a plus sign. We're going to put a plus sign in the middle. And what has to happen in the second group is I absolutely have to have the same leftover factor that I had in the first group. And it's guaranteed to work, so I can just write it. I can just write it that way right now. 3x minus 2. And then we just ask the question, what would I have to undistribute to make that happen? Negative 2, okay? Well, now look what we've got. We've got two terms separated by that bright plus sign, right? And each term has a common factor that I could undistribute. The blue factor is a common factor to each term, right? So if I undistribute that, what do I get? If I undistribute the 3x minus 2, what am I left with? What am I left with from the first term? 3x plus, there's my plus sign. From the second term, negative 2. Well, that's just 3x minus 2, right? 3x minus 2 times 3x minus 2, how would I write that? 3x minus 2 quantity squared. Okay? That's way better because nothing we did there was illegal. Everything we did was equivalent to the step before it, right? Everything was equal to what I started with. That is equal to that, which is equal to that, which is equal to that, which is equal to our answer. Okay? Let's try that. You want to try it on the board? Well, let's do one more together of this. One more together. No, or do you want to try it on the board? Well, let's do, okay, I'm hearing some requests for one more. Let's do one more together and then we'll go to the boards. Okay, so what about this then? We got to figure out what are our magic numbers. So they have to multiply. Okay, let's write it this way. So m times n has to equal what?
Did we not find the greatest common factor first?
Oh, yeah. We can factor out a greatest common factor. Ooh, good. So what's our greatest common factor? 3. Okay, so I can take a 3 out of there, and then what's left? Okay, that's good. Now we're left with a trinomial, but at least the coefficients are smaller. So now we need to find magic numbers. So what do we get here? M times n, okay, which is what? Negative 18. M plus n has to equal negative 7. So what numbers multiply to negative 18 and add to negative 7? No.
No, because one has to be negative.
Mm-hmm. Negative 9, positive 2. There we go. Okay, so m, we'll just say m equals negative 9, n equals positive 2. Here's another small hint. If you have opposite signs, when you split the middle term, always put the negative sign first so you get a plus sign in between the two groups. It's just a little bit better because look what happened last time. It wasn't terrible, but we had plus a negative, right? It's better if you just have the second one be positive. Okay, so if we split this up then, what is our middle term going to split up into? Good, so we're going to get the negative 21x is going to become, sorry, this guy right here. I forgot my 3 out front. I got confused there for a second. Don't forget that 3 out front. We've got that 3, and then we're breaking up all of this stuff, right? So now we get, in these brackets, we get 6x squared, right? There's my 6x squared, minus 9x plus 2x. That's how that negative 7x is splitting up, minus 3. Okay, what do we do?
Then we find the greatest common factor first.
Okay, factor the first group. We want the GCF of the first group. So we've still got our 3 hanging out front, and we're working inside the brackets, right? Everything we're doing now, we're factoring inside the brackets. So inside the brackets, we're factoring out, what'd you say, a 3x? Leaving behind what? Minus 3, okay. Okay, plus, what has to happen in the second group? Let me pause for a second. Is everybody good with, before I go further? Maybe I'm rushing. Give me, question? You got it? Okay. Everybody good so far? Okay, so what do I, second group, I know something automatically. The blue stuff is the same. The leftover binomial is the same. It's got to be 2x minus 3, which means what do I have to factor out to make that happen? Which is 1. Okay? So I'll undistribute the blue common factor from each of the 2 terms. I can pull that out front with a 3, right? So now I get my original 3, that GCF that we started with, times the blue, blue 2x minus 3, and then what's left behind? Everybody agree? Just a 3x plus 1. If I take that 2x minus 3, pull it out front, I'm left with a 3x plus 1. No. No, because look, I've got 2 terms here. I've got a common factor. I'm going to undistribute the 2x minus 3 from the left group and the right group. And then what's left? The left group then, after I undistribute the 2x minus 3, the left group only has a 3x. The right group only has a 1. So here's the plus sign. Sometimes it's easier to track if we do this. Does that help? Everybody see that? So there's the plus sign that separates the 2 groups. Okay. Give me 1 to 5. How we doing? Okay. All right. Try one. Oh, okay. Never mind. Don't try one then. We have 2 minutes. We'll try one tomorrow.